Welcome to This Explainer. Today we're completely demystifying the CBSE Class 12 Artificial Intelligence syllabus. That's subject code 843, to give you a crystal clear, highly actionable blueprint to mastering this cutting-edge material. So, whether you're gearing up for your board exams or you're just genuinely curious about how modern AI is being taught today, you are absolutely in the right place. We're going to break down this entire curriculum chapter by chapter, turning what looks like a massive syllabus into an easily digestible roadmap. Let's get into it.
Here is our agenda for today. We'll kick things off with your 50-mark exam blueprint, then move into mastering data and analytics, explore vision and visual programming, unpack neural networks and Gen AI, and finish up with the power of storytelling.
All right, Section 1, your 50-mark exam blueprint. Let's decode the evaluation structure. Knowing the rules of the game is absolutely crucial to winning it. So let's talk stakes. Your final written board exam is exactly 50 marks. That means the remaining 50 marks come entirely from your practical evaluation. For this written sprint, you've got exactly 2 hours. It's a highly strategic environment. You don't have to boil the ocean here. You just need to efficiently demonstrate your grasp of the core concepts within a very specific framework.
Now, what's really interesting is how those 50 marks are split right down the middle. Section A gives you 24 marks of objective-type questions. Think of these as testing your quick recall and conceptual clarity. And the best part, no negative marking. Then Section B brings 26 marks of subjective questions. This is where you'll need to actually explain concepts, like the data science methodology or write out short Python snippets. This balanced approach means you really need both rapid-fire knowledge and the ability to articulate complex ideas clearly.
Moving right along to Section 2, Mastering Data and Analytics, where we'll focus on Python pandas, big data, and methodology.
Look, artificial intelligence is practically useless without data. You have to be a data wrangler first. Before we can even think about building advanced AI, you must master fundamental Python libraries, specifically pandas for data frames and NumPy for arrays. Think of pandas as a digital spreadsheet on steroids. It lets you import massive CSV files, manipulate rows and columns, and crucially, handle missing values using functions like drop an A or fill an A. You simply cannot train a neural network on broken data, so this is where your AI journey actually begins.
And as your data scales up into big data, you have to rapidly navigate the 6 V's. These basically define the complexity of modern information flows. Volume is the sheer size. We're talking terabytes of data. Velocity is the insane speed at which it's generated. Variety covers the different formats, structured, unstructured, semi-structured. Veracity is all about trustworthiness. Value is the actual business insight you can extract. And finally, variability refers to the inconsistencies in those data flows. Grasping these means you truly understand the modern data landscape.
To actually handle all that data without losing your mind, experts like John Rollins developed the iterative data science methodology. This framework ensures you don't just blindly throw algorithms at a dataset, right? You start by defining the business problem, then collect and prepare the right data, build and evaluate your models, and finally deploy them, gathering feedback to constantly improve. It's a continuous, dynamic cycle of refinement.
Okay, Section 3, Vision and Visual Programming, covering OpenCV and the Orange data mining tool.
Having mastered raw data, we now give our machines the ability to literally see. But remember, a computer doesn't see a picture of a cat. It sees a giant matrix of RGB pixel values ranging from 0 to 255. By translating images into these grids, the computer vision process allows systems like OpenCV to extract meaningful features, things like edges and corners. Through steps like noise reduction, normalizing pixel values, and feature extraction, machines eventually perform high-level tasks like object detection. This is exactly how self-driving cars navigate our streets today.
Now, when it comes to analyzing data, you don't always need to write hundreds of lines of Python code. Enter the Orange tool. It acts literally like digital Lego blocks for data, letting you bypass traditional syntax entirely in favor of visual programming. This is a huge game changer. It completely democratizes AI because you construct your pipeline visually. It's incredibly intuitive and lets you focus on the logic and outcomes of your models, rather than pulling your hair out over a missing comma in your code.
The way it works is through the Orange widget catalog. You can seamlessly drag, drop, and connect widgets across a visual canvas. For instance, you just drag a file widget to load your CSV, connect a line to a scatterplot widget to visualize it, and then link it to a tree or logistic regression widget to actually train your predictive model. It's an incredibly empowering, hands-on way to experiment with complex concepts like clustering and classification in real time.
Section 4, Neural Networks and Gen AI. This is all about mimicking the human brain to create.
We are moving into truly cutting-edge territory now. Artificial neural networks built with frameworks like TensorFlow actually mimic biological neurons. They use weights, biases, and a fascinating process called backpropagation to continuously fine-tune and reduce prediction errors. It's kind of like learning to ride a bike. The network makes a guess, calculates how far off it was, that's the loss, and then sends a signal backwards through the network to adjust the weights. This backpropagation is the absolute core of deep learning.
And this leads us to a massive paradigm shift happening right now. For a long time, AI was primarily discriminative, learning boundaries just to tell us if an email was spam or not. But generative AI? That's a whole different ballgame. Using tools like generative adversarial networks or LLMs, it learns patterns to autonomously create entirely new, highly realistic content. It actually studies the underlying distribution of the data to paint new pictures, compose music, or write full essays.
A perfect example of this is how open-source large language models are disrupting the tech industry. Meta's Llama is the prime case study. Instead of relying on hidden, proprietary data silos, Llama proved that by using efficient training techniques on publicly available internet data, we can create scalable, highly capable conversational AI. It's fostering incredible transparency and pushing the whole research community forward.
Finally, Section 5, the power of storytelling, combining data, visuals, and narrative.
Here's the hard truth. None of these technical skills matter if you cannot communicate your findings to the world. You could build the most accurate neural network on the planet, but if you can't explain why it matters to a stakeholder, its value is essentially zero. That's where the 3 pillars of data storytelling come in. Data gives you the factual foundation, visuals, like heat maps or scatter plots, provide clarity. But it is the narrative that guides your audience, explains the why behind the numbers, and actually drives them toward making a decision.
To build that narrative, we use Freytag's pyramid. It's the ultimate structural arc to make your presentations unforgettable. You don't just throw a graph on a screen, you set the scene. You introduce a conflict, say dropping sales or rising costs. You reveal the climax found in your data analysis, and you conclude with a data-driven resolution. This is quite literally how human beings are wired to absorb information.
So, as you prepare to conquer this 50-mark board exam, remember that the ultimate goal isn't just passing a test. It's about questioning how these incredibly powerful tools will shape your impact on the world. You now know the exam structure, the Python tools, how machines see, how they learn, and how to communicate that intelligence. This syllabus, it's just the beginning. The real question is, what problems are you going to solve with it? Keep exploring, keep learning, and I'll catch you in the next explainer.